we're on a new section. And we're on 5.2. And we are going to be using a unit circle. I actually got a unit circle. I just went online and I found it. If you like the one I'm using, I'll put it in Canvas and you can use it. It's this guy over here. Maybe bend this a little bit. There we go. You like that one? Nice and big. If you, do you want me to put this on Canvas somewhere under resources and you can print it yourself? If you've got a better one, use that. So first part of what's 5.2 is that we are going to use our unit circle to find some or all of these 6 trig ratios using the fact that it's a unit circle. And if you know the coordinates of the point, you can find the cosine, because it'll be the x coordinate, the sine, which is the y coordinate, and the tangent, which is the y coordinate divided by the x. And if you want the secant, don't you just turn this guy upside down? If you want the sine, turn this guy upside down. You want the tangent, turn this guy upside down. Remember the rules about the other 3 are just reciprocals of the first ones. And we're going to look at 3 distinct kinds of situations. Negative angles, angles between 0 and 2 pi. They're the easy ones, right? They're already on the circle. We should be able to get them. We're going to deal with sines, cosines, and tangents of negative angles. And lastly, sines and cosines, tangents and cotangents, whatever, of angles that are bigger than 2 pi. So let's pick some of the first kind. That's angles between 0 and 2 pi. So if you're being asked, for instance, to find the sine of pi upon 4, there's your coordinates. Now, what is it? I know it's the same number, but what is the sine, the x or the y coordinate?
It's
what
the
is
y
the
coordinate.
It's the y coordinate. See that guy underneath there? You may want to have that written down somewhere. So I'll put that in because this is notes. It's the y coordinate. And in this case, the y coordinate is √2/2. Suppose someone asked me to find the cosine of 7/6 pi. Well, I know the cosine is the x coordinate of that point. So you find 7/6 pi. You see the coordinates here? Excuse me. And the x coordinate is -√3/2. Can you imagine how quick your homework's going to be when all you need to do is figure out where on this circle the guy is, and you're going to write some combination of x and y. So suppose I went and said I would want to get the tangent of 5/3 pi. Now the tangent is the y coordinate divided by the x. So in this case, you're going to have probably some work to do. So there's 5/3, so here it is here. And the y coordinate is that guy. And the x coordinate is that guy. So let me tell you a little trick. Whenever you have a fraction that's made up of a fraction on the top and the fraction on the bottom, you can eliminate the two. So they essentially cancel out. Have we go with that? √3. Right. Now, if you want to see why does that work, essentially a fraction can be thought of as a division. And then you can take and do the reciprocal thing, and then you can cancel. You see how it works? That's why it works. I just think of it as, you know, if it's the same guy top and bottom, you can cancel, right? If the same denominator in the top and bottom, you can cancel. How about cosecant of 5/4 pi? Right, well, I find 5/4 pi, it's this guy. What is the cosecant? 1 over which coordinate? And I don't want to have to flip this up and show you. Can anybody just remember it?
1 over y.
Okay. And the cosecant, just like she said, she nailed it, right? 1 over y. Now, 1 over y is going to be 1 over, I've lost the darn thing, the y coordinate, negative root 2 over 2. Now, that's a little bit messier. So think of that as being 1. Well, there are 2 ways to think of that. Isn't that just the reciprocal? Like 1 over something means reciprocal. So one way of thinking about it is just to turn it upside down. Okay. Another way of thinking of that same question is to think of it as 1 divided by the fraction on the bottom, which becomes 1 times the reciprocal. And there's the same answer that I just got. Now, is that considered the best form for an answer? So let's say, since I'm running short of room, let's do it on the next piece of paper. We already know that, that the cosecant of 5/4 pi is going to be negative 2 over root 2, right? That's where we got to. I'm going to rationalize the denominator, which basically means multiply by that special version of 1. And now we have this. Can negative 2 over the square root of 2 be simplified? Can't it? And what do you get when you simplify it then?
You just get the
Negative 1.
square root 2.
Well, they cancel out and give you 1, and 1 times the guy gets you that, right? So you get negative square root of 2. Would you agree that that is actually worthwhile in this case? Have you noticed that a lot of the times when you rationalize the denominator, it looks just as ugly or maybe even slightly uglier, right? But in some cases, and here's one of them, it works out really well. Now, all the questions I've done so far have been in radians, but couldn't you equally do them if it was the cosecant of 300 degrees or the sine of 210 degrees, right? It would be the same thing. Wouldn't you just find the coordinate? And is it the x coordinate that the answer is? Is it the y coordinate? Is it some combination of them? And you would get that. Are we good with that? Do I need to do more of these, or do you feel comfortable about angles between 0 and 2 pi and using the unit circle to do them? Okay, I get a thumbs up on that. I'm happy. So the questions that I just talked about, right, are like questions 1 and 2. So let's do the second lot, which I believe, I'm trying to be consistent here, negative angles. So you're going to be asked to find the exact value of things like the sine of negative 2/3 pi. That would be an example of it. There is no negative 2/3 pi's. In fact, there's no negative angles at all in this picture, right? Because unit circles are designed from 0 to 2 pi or 0 to 3/6, right? That's the usual way to write them. So that means we have to convert this angle into another angle that's equivalent to it, right? In other words, the same as it. What do you do to negative 2/3 so that it becomes an angle in here?
Add 2 pi.
Add 2 pi. Agreed? Now, I'm careless, so I'm going to show you how I would do that on the calculator, just to be sure. I know what the correct answer better be. It should be 4/3, but let's just check it out. Negative 2/3, add 2 pi, and then go math, number 1, turns the answer. Do you see my 4/3 pi now? If the fractions get really weird, you might want to do this. If nothing else, isn't that a good way of just being certain, right? To make sure you're going to do it right. Now, once you've got to that point, isn't it just basically pick the right spot, and 4/3 better be around here somewhere. Here it is. See 4/3? X or Y coordinate. What is the sign?
Y.
So Y coordinate, and the Y coordinate in this case happens to be negative root 3 over 2. Are we comfortable about how we would do that one? Right. So when your angle is negative, don't you add 2 pi? Right. So let's make it even uglier. Are we good? Now, essentially, shouldn't I add 2 pi to that? And you could, if you can do it in your head, that's great. But negative 21 6, add 2, and then go math 1. And the answer is negative 3, oops, halves pi. Oops, I better do that again. The sine a negative 3 upon 2 pi. Oh, that's not good. It's still negative. So what do I do?
Add another 2 pi.
Okay, so I should be able to just go add 2. Well, I can tell you that's a half. I mean, I could change it in the fraction, but would you agree it's a half pi? So far, so good. Now, if we go to a half pi, it's up here, and we're still looking for a sine, so that's going to be a y coordinate. And the y coordinate of this is 1. Looking good? Can you just keep adding 2, right, 2 pi until you get a number that isn't negative anymore? And that's when you stop. Right. Now, if you know it's really big, couldn't you save a little bit of work by adding 4 pi or adding 6 pi? Because you know it's going to take at least that amount. And that might save a couple of buttons in your calculator, but you could do it. Let's try cotangent of, I'm going to pick a really weird question here if I can find one. I think, let me check. Is that going to work? It's hard to do one on the spur of the moment, but I'm trying to get to a particular place and I'm not having an easy time of it. There, got it. Okay, I want to find the cotangent of negative 7 halves pi. Okay, so if I just do the calculator a bit, there's negative 7 halves, and if you add 2 to it, would you agree that's still negative? And if I add 2 to it, we get the answer I was looking for, which ends up being a half. Now, the formula for a cotangent is x over y. And if you go here, oh, I didn't get this, the weird one. Well, I did get a weird one, but not the weird one I was hoping for. 0 over 1. Okay, what's the answer to 0 over 1?
Just be 0.
Just be 0. Now, since I've got this guy set up, let's do the tangent, which is kind of the weird one I was trying to get. And would you agree it's still a half pi, right? You go round and round, you still get a half pi. Now, in this case, it's going to be y over x, and that's 1 over 0. And that's the really weird one I was trying to get. What is 1 over 0?
Would you call that undefined?
I would call it undefined. And I believe when you do WebAssign, you just type in undefined. It might be in capital letters, but that's what you would do. But I'm going to leave this guy here so that those who don't have a unit circle can see it. And I'm going to give you a couple of questions, just 2, on what we've covered, right? So I want to find the cosecant, well, 2/3 pi, and I want you to find the cotangent of negative 7/3 pi. And you've got 1 minute, go for it. Okay, time up. Cosecant a 2/3 pi. Well, that one should be using that coordinate there, agreed? What is a cosecant? 1 over what?
Y.
And in this case, 1 over the square root of 3 upon 2. Now, I don't know if you had enough time to fix that one, but that ends up being 2 over root 3, and then 2 root 3 over 3. Did you have enough time to finish that? Okay, right. This guy is negative, right? Agreed? So you added 2 pi and it didn't work, and you added 2 more pi's, didn't you? And what did you finally get then? What is this the equivalent of?
5/3 pi.
Agreed. And that means that we are going to be where my finger is right now, right here. What is the formula for a cotangent in terms of x's and y's?
X over Y.
In this case, it's a half over that guy. Did you use the little trick that you can rub out the 2's? And then if you tidy it up by rationalizing the denominator, you would get that. Do you feel comfortable that you can use the unit circle to get sines, cosines, cotangents of angles that are in 0 to 2 pi or angles that are negative? Do you feel comfortable you could do those now? Okay. So there's only one more situation in this bunch that I want to deal with, and that is angles greater than 2 pi. And that basically means we've covered every eventuality. So angles that are greater than 2 pi.
Didn't we just did one that was like this. It was
We
the
did.
7 pi over 3.
Oh, we didn't? Oh, well, it was a negative 7 pi over 3. So it was very similar.
Okay.
But this is a bigger than 2 pi, but positive and bigger than 2 pi. So we are going to be looking at how to find the sine of 9/4 pi, or the cosine of 19/6 pi, or the tangent of 22/3 pi. There, that's probably plenty of practice. When the angle was negative, didn't you keep on adding 2 pi until it ended up inside this circle? Similar kind of process here with a little change. What do you do to angles that are bigger than 2 pi? You don't subtract, oh, I almost said the answer. You don't add 2 pi to it works, don't you do
Subtract 2.
Subtract, I gave it away. But if you take this guy and you subtract 2 pi, can you trust me that you get 1/4 pi? Now, if you take this guy, which is 19/6, and you subtract 2 from it, and then you check that it's okay, do you see 7/6 is in the range? And what do I mean by in the range? I mean, it's one of these guys around here, right? And if you take 22/3, which is the next one, and you subtract 2 from it, can you trust me that's bigger? Is that bigger? Let me check, it might not be. It's 16/3. Isn't that too big? So I'll take away 2 more. And we'll see what that looks like. 10/3. Okay, take away 2 more. This one's going to work, isn't it? Yeah. Can you see that you get to a number, in this case 4/3 pi, that is in this fella? Now, where is 4/3 hiding? It's down here, isn't it? Yeah, so it's here. And all you need to do now is have a good memory. Isn't the sign the y coordinate? So let's do 1/4 pi, which is here, and the y coordinate is √2/2. Now, if you want the cosine is 7/6, which is here, and the cosine is the x coordinate, so it's that guy. And if you want to do the tangent fella, it's the y divided by the x, and the angle we're looking for is 4/3, which is here. So it's going to be -√3/2, the y coordinate, divided by -1/2, the x coordinate. Okay, anybody brave? What does that cancel down to, simplify to?
√3/1. Yeah.
Yeah, positive √3/1, which I'll just call positive √3. Are you comfortable with angles that are bigger than 2 pi, how you would find the exact value? Do I need to do more of them, or we kind of, you know, what's the phrase? I'm flogging a dead horse, right? Or a dead donkey, or whatever the phrase is, I can't remember. We're good? Right, let's move on. You thought that was funny, yet you didn't think my one about the dead ringer for it. You lot are strange crowd. Okay, I'm just scanning through. Okay.
That's because you just have an advanced sense of humor.
Who, me or you?
You.
Oh, that was a good one. Yeah, you recovered well there. I like that. That was good. Okay. What we've just done, right, so far, gets you through questions 1 to 7 in the homework. Right, if you're wondering where those questions are, 1 to 7. Right, we're going to look at another thing that we've kind of touched on. It's just adding to it, I guess. Sometimes they do something and then they come back to it and they do it again and then add a little bit. So still on the unit circle, but this guy's no good because none of the guys are going to give me have anything to do with typically the unit circle. And you're going to get a point, and let's just say for argument's sake that this point here is 3/5, 4/5. Now, if I join this guy to here and I join this guy along the x-axis, then this angle in here is called theta. Actually, for some reason better known to themselves, they call it t. So I might as well call it the letter of the alphabet they want. We can find all 6 guys. We can find the sine of that. I would call it theta, but they're calling it t. We can find the cosine of it. We can find the tangent of it. We can also find the cosecant, the secant, and lastly the cotangent. So we can find all 6 trig ratios by only being told the coordinates of the point that's on the unit circle. And you remember these guys? That's how we're going to do it. You notice I've got thetas. I like theta. I don't like t. I don't know why I don't like t. I like theta, right? It's the same information. So if I wanted to find the sine, isn't it going to be the y coordinate? If I want the cosine, it's going to be the x coordinate. And if I want the tangent, it's going to be y divided by x. If I want the cosecant, did I call that a cosecant? Yes, I did. It's going to be y over the 1, the secant 1 over the x, and this guy x over y. Are we comfortable with those combinations? We've been using them.
So aren't those coordinates essentially just lengths?
Well, they're how many to the x and how many up.
Well, yeah,
So-
I'm saying like the 3/5, the 5 would be the hypotenuse, correct?
Yes, the 5 would be from the hypotenuse. You're correct here. So, I mean, if I built this little triangle, right, just this little guy here, wouldn't, if you're looking at it as 3/5, mean this would be 3 along, right? This would be like 5 along, and this 4 along, and this would be like 5. It would be like, you know, like that. Is that what you're thinking?
Yeah.
Yeah.
So is that essentially what we're doing?
Yeah, but we're taking that and shrinking it down to a unit circle. But we're taking a 3/4 triangle and shrinking it to a 3/5, 4/5, 5/5, which is 1. So it's basically going to be a 3/5 by 4/5 by 5/5, which is going to be called 1. But as far as answering these questions, it's easier to just use the x and y coordinates. So that's why we're doing it this way. So if you want to know the sine of this angle t, it's going to be the y coordinate. It's going to be 4/5. And if you want the cosine, it's going to be 3/5. And if you want the tangent, it's going to be 4/5 divided by 3/5, which we can simplify down to 4/3. And the cosecant is just turn me upside down. The secant is just turn this guy upside down. And the cotangent is turn this guy upside down. I like thinking reciprocals for these three. Isn't it just less work if you already know these ones to just flip them upside down to get the other one? Right, reciprocals. Are we good? Now, not all of the guys that you're going to do this are going to be as they are here in the first quadrant. Couldn't you get a guy over here? Agreed? Now, in this question, won't x be a negative 3/5 and a y be a positive 4/5? Won't the numbers look almost identical because this question used very similar values? Wouldn't the answer just be, what would the difference be? Well, because that's negative, won't this be negative and won't this be negative? Agreed? Won't the tangent be negative and then negative again? Do you notice that that's pretty much the only difference that you would get? Right. So as long as you have these 6 formulas and I tell you or they tell you the coordinates of the point on the unit circle, isn't it just a matter of using the values and writing them down and maybe occasionally making them look a little bit nicer? Are we good with that? Right. Do you want to see another one of these? Are you quite comfortable about that kind of question? What do you want? Another example of this, or you'll be good? Another one? Oh, no or yes? I'm
I
not
think
sure.
we're good.
Okay, okay, we're good then. That's what you meant. That's fine. And that's why I want to see lots of faces, because then even if you don't want to volunteer, I can look at your face. Give an example. When I'm doing something and I'm looking, I might be looking at, well, I can see a lot of you, but I might be looking at Ali or Jason, and I'm writing something and they do this. Do you notice that you do that even without knowing you're doing that? what do I pick up when somebody goes like that when I'm writing something down? That they've got it. It makes sense to them. Isn't that the nod of, see, Ali just did it there the now when I went and said that, and you said, yeah, that's what it means. Do you notice that you don't even know that you're doing that half the time? But that's the kind of feedback that's helpful for me. Now, I also want to get the other kind of feedback, which is the deer in the headlight look. You ever seen that face? Where, what the heck is he doing? Right? Because then if I see that face, I can say, okay, I really should maybe do some more of these questions, or maybe phrase it a different way, or, you know, whatever it is I'm causing, you know, an issue before I move on. See, and right now I'm left with, for most of you, because you don't show me your faces, are we okay? And I might be saying, are we okay? And nobody's complaining, so I'm moving on. But George, hopefully there's not a George in the class. George didn't get it, but George is too shy to tell me he didn't get it. And George would have benefited if I'd done another couple of questions and I'd maybe phrased it a little bit differently as well. So you see, that's my world, right? So start switching on those blinking cameras so I can see deer in the headlight or nods, right? Both are good information to us. So the next group of questions in this section return to a place that we all know. Remember that one? It's to do with quadrants. And they are going to do some questions that we have seen before. You're being asked, is this expression, cosine t times the sine of t, is it positive or is it negative? And the other piece of information is that they're going to tell you which quadrant it's in. Okay, so how do you use this? Cosine of t. If you are in the fourth quadrant, would you agree that the cosine is positive? I put little circles around them just to emphasize it, right? In the fourth quadrant, isn't the cosine a positive answer? What is the sine in the fourth quadrant? Positive or negative? Negative. And wouldn't you agree that if you take a positive thing and you multiply it by a negative thing, isn't the answer negative? And so, very quick question. Don't you just put a dot there and you're good to go? Now, I'm going to be sneaky with you here. And so I'm telling you right now, this is a trick question. The cosine of t times sine squared t. If you're not aware of what sine squared t is, it's just a simpler version of writing that. In trig, we call it sine squared rather than writing sine t all squared. Would you agree there's a lot of brackets here and that means the same, right? And yeah, I'll keep it in the fourth quadrant. Told you it's, be careful, trick question. Positive or negative?
Wouldn't it be positive?
I like your answer. Aidan, tell me why. You're right.
Well, because in the fourth quadrant, cosine is positive, and anything negative squared is also positive.
So even although the sine is negative, when you square a negative, just like Aidan said, isn't it always positive? You see that combination then means that this is positive. So look carefully at the expression, right? Because they might just sneak that up on you, right? Let's try some. It's not meant to be a trick question, but it is meant to have a lot going on in it. It's going to be the tangent of t times the sine of t, all divided by the cosecant of t. So I'm going to make that one a lot messier. And somebody tell me a quadrant, except the first quadrant. 2, 3, or 4. 2. Let's pick quadrant 2, right? So if you take the tangent function, would you agree in quadrant 2, the tangent is negative? Great. What is the sign in the second quadrant?
Positive.
Positive. Now, we don't do an awful lot of these cosecant, secant, cotangents, but you can still use this table to figure it out. Isn't the cosecant just 1 over the sine? Right. So won't the cosecant do exactly whatever the sine does, right? So if the sine's positive, so will be the cosecant, and so on. Would you agree then that the cosecant of t is in the second quadrant is also positive because the sine is positive there? What do you get when you have a combination of multiplying and fractions, which is made up of a negative and a plus and then another plus?
Negative.
And agreed. Does that make sense that that combination is negative? So I'm about to give you the ugliest version of that question I can think of, and you're going to do it. And if you can do this one, you can do any of them, right? Because I'm picking the weirdest, ugliest, you won't even see this. So it's going to be a sine of t, a cosine squared of t, and a tan of t. And on the bottom, it's going to be a cosecant t and a secant t. And it's going to be in the third quadrant. Right, you got 1 minute, plus or minus. Last seconds. Now, you know you've got a 50-50 chance of guessing this correct. So if you answer, you are committed to telling me what all the bits are equal to as well, okay? So as long as you feel comfortable about that, you can do it. Positive or negative?
Isn't it positive?
Okay, so
That's
let's, that's a good sign that people agree with you. Okay, let's take it one at a time. In the third quadrant, what is the sign?
Negative.
In the third quadrant, although it doesn't really matter which quadrant, what is a cos squared?
Positive.
Agreed. Remember, Aidan, after the square is positive. Can't you just do that without looking? Right, what's the tangent going to be in the third quadrant?
Positive.
I agree so far. Cosecant,
Negative.
isn't it just like the sine?
Mm-hmm.
And secant in the third quadrant.
Negative.
And if you put all that combinations together, what do you get?
It's a negative over a negative, so it has to be positive.
Are you sure?
That's what I think.
There's 2 negatives. In the,
Uh-huh. So what did 2 negatives give? You were 99% there.
Positive.
Yeah. So won't those 2 give you a positive?
Oh, dang, so close. Okay.
Yeah, but exactly. You were so close. I mean, you did all the hard work, right? You got all the bits. But kind of, yeah. Are we good? Right, I'm looking for faces and whatever. Can we call this type of question done now and move on? Or do you want to see some more of these? Bear in mind, this is much uglier than anything you're going to be asked. Okay, I got lots of notes, I'm happy. Okay, let's, I might keep that for a while. You're never sure what you're going to get. Oh. Now, Has anybody seen that before? It's the trig identity. Sine squared of an angle plus cos squared of the same angle always equals 1. You recognize that guy? Right. I like the, yeah. Chris?
Somebody just asked a question in the chat about the last question, I believe.
Oh, I didn't catch that. I don't really see the chat. So let me close out and find what the chat said, and I can maybe answer that question. Is this going to be a question in the homework, or is this a learning step? It is a learning step. None of the homework questions were as ugly as the one I just did, right? So that's the answer to that person's question. Right, let's return here. Now, what we're going to do is we're going to rearrange this formula twice. One of them is to rewrite the sine of t in terms of cosine, and the other's the other way around. So if you take cos squared and subtract it from both sides, you get that. If you then take the square root of both sides, you will get this. But bear in mind, because you have taken a square root of both sides, there are two possible answers. Only one of them will be correct, and the one that's correct depends on which quadrant angle T is in, right? So if angle T is in the first quadrant, won't we pick a positive number? If angle T is in the second, we'll pick the positive one. But if angle T is in the third quadrant, or if angle T is in the fourth quadrant, won't we choose the negative square root, right? So when you have to decide, is it the plus or the minus, because it has to be one, not both, you need to know which quadrant your angle is in. Right? So that's the first guy. Put a little bubble around him so I can keep track of him. Now, if you take the same line, but this time you subtract sine squared from both sides, and then you take the square root of both sides, you get that with the same plus minus situation. So far, so good. Okay. Now, how to use these is really more important. So suppose I tell you that the sine of t is negative 5/12. Okay, the sine of t is negative 5/12. And I tell you that t is in the third quadrant. Right, so I tell you that as well. You can use these to find everybody else. Right? That means finding the cosine of t, the tangent of t, the cosecant, right? All 6 ratios. Want to find out how? Let's go. Let's do the cosine first. According to the cosine, isn't the answer going to be the square root of 1 take away sine squared t? You agree? Now, positive or negative? Remember the choice. We have to pick one. If the angle T is in the third quadrant, right? This quadrant here, will I get a negative or a positive cosine?
Negative.
Negative. And now it gets a bit messy, but here goes. It's 1 take away the sine squared. You happy about the sine of t squared being this guy squared? And it's negative the square root of 1 subtract 25 144s. And that's, what is that? Don't know what that is. 1 take away 25 144s. And then math fraction. It's 119. You would have guessed that. 144s. Are you still with me? Right. Wish I'd started this a little bit earlier, but I'll shove it up a little bit. Here goes. I want this to look pretty. And so you can take a square root and separate it into 2 square roots. You remember that that was allowed, right? Now, what's the square root of 144?
12.
12. So we now know the cosine of t. I'll put little circles around them, right? We already know this one because they told us, right? Now, if you know this one, can't you just tell me without any extra work, right? You don't need any of this stuff. Can't you tell me the cosecant of t? If you know the sine of t is this fraction, what will the cosecant of t be?
1 over negative
Right.
5.
And I think of it as turning the fraction upside down, which does the same job. We agree? Reciprocal, right? Turn me upside down. Now, I now know that the cosine is this ugly guy. So won't the secant of t just be turn me upside down? And I don't have space, but couldn't I make that look slightly prettier? So haven't we now found 4 out of the 6? Right, there are only 2 to go. Agreed? 2 to go. Now, if you want to find the tangent of an angle, isn't it y over x? Remember that guy? And if you tell me the coordinates, that's easy. But I can adapt this formula. What's the y coordinate? The sine of t or the cosine of t?
The sine.
Are you happy that the tangent of t can be found by just taking the sine and dividing it by the cosine? You comfortable with that? And since I know what the sine is, it's negative 5/12. And I know what the cosine is, it's negative the square root of that over 12. And I can cancel the 12s and the negatives. Don't I end up with an answer that looks like that? Are you happy about where the tangent came from? While I'm at it, why don't I just write down the cotangent then? Won't it be this guy? If I wanted to, and I probably should, shouldn't I make that look pretty? By rationalizing the denominator. Do you see that if you only tell me the sine or the cosine and the quadrant that it's in, right? That's the only thing you tell me. Can't I get the exact value of all the other 5 guys? Right? As long as it's a unit circle, these formulas work perfectly.
Can't you also just use SOHCAHTOA too?
If you created a right angle triangle, you would be able to do SOHCAHTOA. The fractions would be, well, that wouldn't really be a fraction, you're right. But in the way that they're doing this question, that's kind of the way they want us to do it, right? They want us to do it more algebraically and less with right angle triangles, but you would be correct. Okay, this is 15. You're being told that the tangent of t is 1/9. And that it is in quadrant 3. And let me show you Aaron's way of doing it, because I think that sometimes that might be a nicer way to do it. What is SOHCAHTOA version of tan? What's the tangent equal to in SOHCAHTOA?
Opposite over adjacent.
Great. So if I build a right angle triangle, is this what you were kind of thinking of when you were mentioned it a few moments ago?
Yeah, it's just, yeah, I got it. Yeah.
So the opposite is 1 and the adjacent is 9. And I kind of need that one, don't I, if I'm going to get all the ratios. What is the hypotenuse going to be in this question? You could probably do it in your head. The square root of what?
Square root of 80.
How much? Want to
80.
change? Want to think again?
Is it 82?
Yeah, you're adding.
Oh,
82.
you're right. Yeah, yeah, yeah.
Yeah, 82. There we go. Now, from this triangle, couldn't I do the exact same set of questions? Couldn't I find all 6 trig ratios? But there is one extra kicker in the tail here. Did you notice that the angle is in the 3rd quadrant? Right? So I'm going to go through all 6 ratios. I'm only going to write down the numerical value. And then we're going to figure out what does this do? You know, in other words, what does this change? Right? So if I was going to find the sine, it would be opposite over hypotenuse. And the cosecant then would be turn me upside down. If I wanted to do the cosine of t, adjacent over hypotenuse. And the secant would then be turn me upside down. And if I wanted to find the tangent, which I already know is a 9th, then the cotangent would be turn me upside down. But now I'm going to factor in this piece, right? This piece here. It's 3, 3rd quadrant. In the 3rd quadrant, what is the sine? And obviously the cosecant. Positive or negative?
Negative.
Is there anybody else who's also going to be negative in this story?
The cosine and secant.
So can you see that the SOHCAHTOA works, but you have to incorporate the quadrant that the angle T is in? I kind of like that way a little bit better than the other. Right? That's fine. Are we cool with that? Right. Okay. So now that I've seen that one, yeah, just because they want us to do it one way doesn't really mean we have to. Agreed? Aren't we really after the answer? And yeah, I can see situations where maybe the one that we did would work better. But I'm kind of changing my mind a little bit. So I'm going to set this one up, but not actually do the whole thing. And I'll put a little reminder here of SOHCAHTOA. Well, the secant of t isn't really designed for SOHCAHTOA because there isn't a secant in here, isn't it? It's sines, cosines, and tangents. But I do know a property. If the secant is 9, right, what's the cosecant?
1/9.
1/9. Oh, and just to keep this question correct, the information that they gave us was that the secant of t was 9 and that the sine of t was negative. Now, don't we need to know what quadrant you're in to get all the plus minuses when we're finished? That one's a bit sneaky. Right, if the secant is 9, doesn't that mean the cosine is positive? You agree? The secant is 9, and the cosine is positive, could be here, or it could be here. Agreed? Isn't that the 2 places where a cosine could be positive? 1st quadrant or 4th quadrant. Now, they also told us that the sine is negative. Now, if you look at the places where the sine is negative, it's these 2 quadrants. Well, when you put them together, doesn't that mean that it has to be in the 4th quadrant? So it was a sneaky way of telling you which quadrant without telling you which quadrant, right? You had to do that. Now, once you've got this guy set up, and this is almost as far as I'm going to take this one, because we're getting pretty close to the end, is there's your angle T, opposite, adjacent, and hypotenuse. And for a cosine then, isn't the top guy the adjacent? And the bottom guy is the hypotenuse. So we're comfortable with that. So I know that this is 9 and this is 1. Now, are we going to add 81 in 1, or are we going to subtract 81 in 1 and then stick it inside the square
This
root?
time it's subtract.
So this time it's 80, right? So square root of 8. Now, from that triangle, can't you get all 6 ratios? And because you now know that it's in the 4th quadrant, can you also figure out when it's plus and when it's minus? And boom, you're done. So say your last name. And I think we learned some cool stuff today, didn't we? You're smiling. I think that is a good sign. It could also mean that I'm not very good at sarcasm. Which is actually true. I'm not very good at sarcasm. I'm a very literal person.
I was hoping to look at one of the questions I missed.
Sure.
last night.
I'm going to be here
Yeah.
for any questions you want. So
Yeah.
if you want to hang about for questions, feel free. Otherwise, bye-bye.
Can I share my screen, or can you look at my test, or whatever you would prefer?
Oh, is this a test question?
Yeah, from last
Right.
week. One I missed.
Okay, let me get to the share screen thing, if you don't mind sharing.
Yeah, just a second. I might
Okay.
have to get my web.
You found it yet? I'm assuming that you're almost there.
Yeah, getting close. Just have to log in.
Okay, Jason, or anybody, if you got a quick question
Yeah,
while we're waiting.
I have a question about the quiz as well.
Okay, we'll do you after that one.
All right.
Jason, you get anything? Just watching to see if there's any interest in them. That's allowed. You got a question?
So I had a question about the homework.
Uh-huh. Is it a quick one?
So on question, I don't know.
Okay, go for it and we'll
let's-
find out. What it is
Okay.
it something you can tell me that I can write down quickly?
I think so. So it's question 11, and you're supposed to find the reference number for each value of t.
Okay.
And I don't
So what-
remember.
What was the T they gave you?
Yeah. So there's 4 parts, and the last 2, it's t equals 4 and t equals -7. I don't remember how you're supposed to solve one, so it's a whole
Right.
number.
What you're meant to do for those 2 examples, and I'll show you right now because it's easier to show you than it is to say it. What you're meant to do with this guy here is figure out which quadrant it's in and then choose the appropriate formula to get its reference angle. So if you take 4, for instance, right, that's 0, that's pi upon 2, that's pi, that's 3 upon 2 pi, and that's 2 pi. Well, if I turn them into decimals, very rough decimals, this is about 3.14. And this here is about 6.28. This guy up here is 1.57. And this guy here is about 4.71 roughly, right? Now, 4. Would you agree if I was drawing 4, it would be in the 3rd quadrant?
Yeah.
So when an angle is in the 3rd quadrant, the reference angle is the angle, take away pi. So you just write down 4 take away pi. You don't even turn it into a decimal. You just call it 4 take away pi.
Okay.
Right. Now, if you take -7, would you agree that you need to add at least 2 pi to that. Okay.
Yeah.
But if you add 2 pi to that, can you trust me, it's still negative?
Yeah.
So what you need to do is you need to add 4 pi to it. Okay, now I'm trying to figure out which quadrant this guy is going to be in, and he's not going to be nice. Actually, I could do it. Yeah, I could do it that way. So let's find out where that fella lies. He's a -7, and I'm going to add 4 pi to it, and I'm going to get a number about 5.56. So 5.56 means that it's here. So that angle there is here. You with me so far?
Yeah.
So when an angle is in the 4th quadrant, what is the formula that you use to get its reference angle? It's 2 pi, right? Take away the t guy, right?
Mhm.
And so it's going to be 2 pi, take away this fella. And that's going to be 2 pi, add a 7, take away a 4 pi. And guess what? You end up with 7 take away 2 pi. And that's what they're looking for.